So, with that, it's time, and welcome to Secure Networking with Azure and Azure SQL Managed Instance.
That's right.
That's brilliant. It will be a very serious session, as you might have noticed or expected. My name is Nico Neugebauer. I'm a product manager at Microsoft, and my dear colleagues suffer with me for almost 2 years. And I help them to smoothen things, as they say.
And my name is Zoran Rilak. I have been a program manager with Managed Instance for 2 years, similar to Nico. My area of expertise is networking and connectivity, specifically as it regards to Azure SQL Managed Instance.
All right. With that, here is the agenda that we will be presenting today. And we will explain for the 10,000th of times what a Azure SQL Managed Instance is. Then we'll dive onto the Azure networking and the Azure SQL Managed Instance networking. And then Zoran will take over and explain the connectivity scenarios and give you some tips to explore more. I would like to ask to let the questions until the end. We've got a huge amount of content, and unless you want us to lock the door and 1 hour and 30 minutes after not letting you out, because we didn't finish the presentation, please let the questions be asked at the end. I can't hear you. You don't have a microphone, sir. Sorry.
Punt the mic.
Rob. Anyway, so what is Azure SQL Managed Instance?
I don't know. You tell me.
OK, I'll tell you. So Azure is the home of SQL Server, as obvious. But Azure SQL is a family of products. We have 4 different products that are a part of Azure SQL family. Starting with the SQL Server VMs on Azure. It's not like your grandparents' SQL VMs on premises, because we've got a lot of things going on with the SQL YAS extension. You can have a backup configured for your SQL Server instance on VM. You can set up even a pretty complex high availability scenarios with some of the plugins that they have, and it's just the beginning of their story. We also have the Azure SQL Edge. It's best for extending applications to IoT age. Those are YAS and edge computing. Let's talk about the platform as a service. Here we've got 2 offers. Azure SQL Database, the database offer, which is the best when you're building a brand new application targeting the cloud-native capabilities. And if you are, especially if you are going for over 100 terabytes. And then our offer, Azure SQL Managed Instance. It's best for modernizing existing applications. So if you have a SQL Server, you want to migrate to PaaS, this is what our offer does in the middle of all other wonderful offers. So the question would be like, which offer is the best for you? Is Azure SQL Managed Instance the best of the best of the best for everybody?
No.
Oh, yeah, of course not. Because we have some incredible capabilities like .NET CLR, we got the linked servers, SQL agent, etc. But if you need a more granular control, you need to go to SQL VMs. If you need a single database as a model, you should be picking Azure SQL Database with hyperscale. So we run it for you, we provide you a SLA for 9s right now, and with availability zones, we actually give you 4 9.5 of high availability. We also take the backups, so you basically can concentrate on the business that matters to you. With that, let's go into the next section, the Azure SQL Managed Instance and Azure networking. Let's talk about the virtual networks. Anybody here has never, ever used Azure? Please raise your hand. No, everybody who is not running anything in production on Azure? OK, a couple of people. Good. So I'll still do the introduction section, if you don't mind. So virtual networks, most of you at least are aware of their existence. It's a basic building block of Azure networking. It has an assigned IP address space. It can be partitioned into the subparts, which are called subnets. The devices inside the same VNet can communicate with each other by default. The inbound connectivity via public IP addresses, public load balancer, and outbound connectivity is open by default, meaning you can reach out by default. On the DNS front, we have a Azure-provided domain name resolution, and you can also use custom domain name servers. Should we add something about the managed instance, some of the gotchas?
I do believe so. We do have one gotcha.
Which is?
Which is that when you change the configuration for your DNS servers in the virtual network where your SQL MI is deployed, you also need to tell SQL Managed Instance that the configuration has changed. This is because Azure will reconfigure the resources that it knows about, but it cannot reconfigure SQL Server and the virtual machine that's underneath it. Sorry, that's actually running it. So when you change how the DNS servers resolve, either change from Azure to custom or from custom to Azure, also ping SQL MI and let it know so that it can read up the new config. Back to you, Nico.
All right. Let's go a level deeper, which are the subnets. How many subnets can you have in a single VNet? That will be largely determined by the address space you have assigned to your VNet, and then by the individual address space that you will give to each of the subnets, right? So you have a traffic routing with a routing table and the service endpoint, which will allow you to define the routing, and the traffic filtering with network security groups, and allow and deny rules, which you can order like you are used to on the Windows firewall. You have the virtual appliances, which you can also set up, and then the service endpoint policies. Anybody heard about the service endpoint policies here? Anybody's using service endpoint policies on Azure SQL Managed Instance here? Okay, just the two of us, you and I. Service endpoint policies, they allow you to determine which, for example, storage accounts can be reached out from your managed instance. It's a great security measure, and if you are kind of worried about security, you should be investing in that area by default. So any managed instance gotchas you want to add?
Actually, yes, Nico. Good that you remembered. When managed instance, as you will hear later, is when it deploys in a subnet, this subnet is dedicated to managed instance, and you can no longer resize this subnet. What you can do, though, is move the managed instance to a larger subnet. Problem solved.
Does this move happen like with a big offline operation?
It is a big operation, but the actual offline time is very short.
Okay.
It's a regular failover.
Oh, that's brilliant. All right. So how does Azure SQL Managed Instance integrate in your virtual network? So managed instance is deployed in a dedicated subnetwork. You cannot deploy anything else in that subnetwork. But can you deploy something in the other subnetworks within the same VNet?
Absolutely.
Maybe it's even something you should do. We have some filtering rules. We set up some NSG rules, network security group rules. We reserve some specific port addresses, et cetera, et cetera. The subnet is reserved for SQL MI only. That's the key thing you need to know about it. Then, here is a very basic view on the virtual cluster architecture. You can see that we have the one or multiple managed instance within the same virtual machine. We have, besides there, some other services and nodes for monitoring, for baking up. And we have this local endpoint reaching through the load balancer and primary and redundant gateways to access the managed instance. With that, let's talk about how you can connect and what type of the connections can you use for connecting to Azure SQL Managed Instance. First, we have the VNet-local endpoint. Do you still remember what is important about it? You can, actually we have the next slide going through the detail.
We will discuss it, yes.
So the public endpoint is the second one. And the third one we finally announced.
Yesterday.
Yes, so since yesterday, we do have a public preview, full public preview of the private endpoints. And let's dive into each one of them and explain what they mean, what advantages and maybe not that much of advantages they bring. All right, so VNet-local endpoint. It resolves into the following dynamic IP address in the subnet. And one key thing that we have been asked pretty consistently in the last couple of months is, what if I use the local endpoint or public endpoint for that matter, and I will call my managed instance my super secret project, and then code name and the details that nobody should know about, and then it will appear on the DNS. It will be publicly accessible, right? Oh, but can I hide the name of my managed instance? Yes, if you provision a different one. This is a very important issue you need to be aware of. The DNS will be globally resolvable. The IP address is locally accessible and is dynamic, and you can connect to any SQL Server port. Connection can be used by the proxy or redirect, and redirect is highly recommended, but it needs TDS 7.4 or later drivers. The famous or infamous port range that needs to be stay away from, we called it 11K. It's everything and anything within 11,000. Just never, ever used it. We reserve it for different services and different needs. Talking about the public endpoint, this one is available publicly. It has a great advantage. You don't need to do a lot. Also, neither the attackers, right? If you set it up, you do not set it up only for yourself. You set it up for the whole internet. And you're very much welcome from anyone who wants to explore your beautiful, my super secret service that I do not want to share with anybody. So the name will be with just adding of the .public between the MI name and the DNS zone name, globally resolvable. You'll need to connect through 3342, which will map to
1433.
It's beautiful. And you'll use a proxy type as a connection. Then the yesterday announced the private endpoints, you'll get a static IP address in another VNet from which you can connect. It means that you can connect from any application running in any other VNet in a very secure fashion without exposing anything publicly. That's why it's called a private endpoint. So IP address is locally accessible, it's static, the port range will be 1433 only. And you will need to use the proxy type as the connection. You are not limited with one private endpoint. You can set up
hundreds.
As long as you have enough IP addresses. Okay? That's all about me, and then Mr. Rilek.
Thank you, Nico. Let us proceed now that we have looked at the basic building blocks of Azure networking and how SQL Managed Instance operates within it. Let us take a look at some of the connectivity scenarios. Now, keep in mind that we only had so many minutes for this presentation, and we cannot really go very much into depth. But what I've tried to do with this, and what we actually tried to do with this, is offer you basic understanding and some basic scenarios how you can use SQL Managed Instance in specific networking and networking connectivity scenarios. How does SQL MI sit? And I want, if there's one thing that I can ask you to walk out of this room with, there are actually two things. One thing is, SQL Managed Instance is largely compatible with the usual networking and practices and how it's done, how it be done on premise. This is our intentional design decision, because we do want to enable these easy migrations. And the other thing is there are some specificities. There are some specificities that SQL Managed Instance dictates thanks to its current, I have to stress, design and architecture. And there are some specificities that SQL Managed Instance will allow you to do because it can connect into Azure services that are specific to Azure. So without further ado, let's go forward. The first scenario that we'll be looking at is something that Nico has just been talking about, and that is open to the internet. Why would I want to open my managed instance to the internet? Well, I can actually have a very good reason. I'm learning SQL Managed Instance, and I don't really have any production data there, so why not? And maybe, just maybe, maybe I'm an independent software vendor, and maybe I have consumers of my services who for some reason need to access managed instance, but they cannot do so through Azure, nor can I route them through to Azure, because neither of us has direct link connectivity, no VPN, no express route. So in all those scenarios, it's valid to open up a public endpoint. But how do we do this? There are three things that we need to do. Obviously, we'll need to enable the public endpoint. We will also need to allow the inbound traffic on that port, and we need to consider any additional security measures for that part. So to enable the public endpoint, this is fairly simple. You just go to the networking tab, or the, what's the word, blade. Yes, networking blade, and flip the toggle from disable to enable. Would anyone venture to guess why this says public endpoint data here? Yes, Danny. This is a reminder that through the public endpoint, you can only access the SQL query listener. That is what would normally be 1433. You're just targeting it on port 3342. So it's a reminder, do not attempt to engage the public endpoint in any inter-SQL connectivity scenarios like failover groups through the public endpoint. It won't work. Next thing. Once we've done that, the public endpoint is open, but it's not receiving any traffic, even if we try to send it to it. Why? Because the network security group rules on the subnet are blocking it. So to unblock them, we need to add a rule that enables the inbound traffic to go through. And here I've written an example rule that says, if we add an allow rule from my IP address to any port, that's the inbound port or the port of the client connecting, to the range of MI subnet on port 3342 TCP protocol, that works. There are some options here that you can select. You can allow inbound from a broader range of addresses from the internet, or any, which means any internet plus Azure. And you can also scope it to not just exactly the subnet range, you can also scope it to virtual network, or again, open to any. Does anyone care to guess why would I want to put virtual network here, given that my NSG applies to the subnet alone? I will help you here. NSGs, or network security groups, can apply to multiple resources. They can apply to multiple subnets. They can apply to individual NICs. So by doing this here, if I were to put virtual network, I can reuse this NSG and put it on different subnets, and it would open up the inbound connectivity on their respective ranges. So I'm not bound to any particular site or range. After doing that, I also want to consider any additional security measures because, hey, there are trolls lobbing rocks. This is actually a distributed denial of service being depicted here, but typically it's 2023. We really have to be security savvy. If you're not using encrypted connections to connect to anything public, you're doing it wrong. If you're not protecting against DDoS, you're doing it wrong. So I'm not going to move into too many details. I'm just going to say enable Microsoft Defender and consider using a DDoS protection plan. It's really effective. So that's the summary of the first scenario. As I said, if you're just learning SQLMI or there really is no other connectivity pattern, you can route the traffic through public internet to the public endpoint. And then what are the pros and the cons? Well, this is simple to set up, but it also needs additional security measures, and it won't support more involved connectivity scenarios such as failover groups or MI-link. There is a managed instance gotcha. Remember, when you're connecting to a public endpoint, or any other endpoint for that matter, use the domain name. Don't hard code the IP address that just happens to be the one that the domain name resolves to at any given time, because the instance gets moved to a different subnet. The endpoint domain name remains the same, but the IP address of the load balancer will have changed. So always resolve this. I'm not at liberty to say if this will change or not. And obviously, all connections will be of proxy type. Nico mentioned earlier that the other type, which is more performant, redirect type, depends on having an open range of inbound ports. Obviously, public endpoint cannot do that because it only opens one port. So the other scenario would be an upgrade over the previous one, secure operator access. And I really won't dwell on this because I'm assuming most of you are familiar with it. If you do want a secure interactive session, but you don't want to open up the public endpoint to your managed instance directly, you can use a jump server, a bastion host, or point-to-site VPN. Jump server is a common scenario in networking topologies when you need to enable and transition from one security zone to another. This can be any security zone, but in this scenario, we're talking about public internet moving into your secure zone in Azure. A jump server is simply a virtual machine that sits in the virtual network and receives connections from the public IP address. When you log into it, you are gaining access to whatever's in that VNet or whatever's connected to the VNet. There are two ways to deploy this. You can use the VM in the virtual network next to SQL Managed Instance, or you can drop it in a demilitarized zone, so to speak. I'm sure you will be familiar about this term. It's a networking term. Demilitarized zone is a network that is sanitized, pristine, and kept safe by firewalls on all ends. It's a buffer zone that sits between the wild jungle that is the public internet and the orderly, clean environment that we have in our VNets. So we will drop this VNet. We will drop the VM in DMZ virtual network, protected with firewalls. And in this virtual network, we will place a private endpoint. So our managed instance is never fully exposed. The other scenario that I really want to, if you haven't used it yet, is anyone here used Azure Bastion? Can I get a show of hands, please? All right, that's about half. Please take note, Azure Bastion is a really useful thing. So in terms of terminology, a bastion, for those of you who know medieval, a bastion is a protruding architectural component in a fort that's hardened and is used to repel the attackers.
Trolls.
Trolls, exactly. Thank you. So in the networking topology world, a bastion is a computer that sits between a secure zone and an insecure zone. So that is actually a special case for jump servers. In our previous slides, what I was doing is I was installing a virtual machine and securing it. What's the difference? Azure Bastion is a PaaS service that scales automatically. It's managed, it's secured. It protects you against zero-day exploits. It protects you against port scanning. It protects you against a great many things, and it is exposed to the internet instead of any part of your internal infrastructure. Even if it's a VM that's exposed, as in the case for jump servers, you're still exposing your infrastructure. There's still some chance that you have some keys installed there. If not, if you don't do that, you do Bastion, instead you're exposing a part of Microsoft's architecture, and you're also gaining the ability to open up HTML5 connections. HTML5 clients for SSH and for RDP are built into Azure Bastion. So this is I highly suggest you to try this specifically, and especially because it's cost comparable to a basic virtual machine. So really, I would be hard-pressed to find a good reason to use a jump server. The third case, and I really want to run over this. The third case is that you would set up a point-to-site VPN. I'm sure all of you are familiar with this, the little shield icon next to the wireless signal on your laptops. Point-to-site VPN lets your single host computer hook into the network that's on the other side, and then you can route traffic both ways. Fundamentally, the difference is that your computer from which you are connecting becomes a part of the network. Instead of you SSHing or RDPing into a computer and then hacking in SSMS or doing something that's on a remote computer, no, your computer becomes a part of the network. So this is convenient, and Azure, of course, supports it. All right, so what did we see? We looked at a secure interactive SQL session, again, through public internet, but it is more secure. All three are more secure than the public endpoint for various reasons. All three will allow you access to the VNet-local endpoint, which is what we couldn't have done with the public endpoint case. But they are more involved, and of course, due to additional infrastructure, they will incur additional cost. Third scenario, secure connectivity inside your company's Azure presence. So we're now past just playing with SQL Managed Instance. We're past just logging on as a single operator. We're looking to enable connectivity scenarios where there are other applications and other virtual networks involved. So there are three ways to do this: virtual network peering, VNet to VNet VPN, and private endpoints. Virtual network peering is the quintessential model, or at least in the SQL Managed Instance world, hopefully until yesterday, to bring the VNet-local endpoint, or to bring the connectivity for SQL Managed Instance into some other part of Azure where you have some other services running. Remember, we're not talking about other tenants, we're not talking about hybrid. Everything is up in Azure in the same cloud for now. So when you peer networks, you're essentially setting up a two-way connectivity tunnel between the two different address spaces. And this is important. The two virtual networks connecting must have non-overlapping ranges. Otherwise, you're going to run into some very iffy things in terms of where packets go. And maybe it's not even supported. I admit I had never tried it. And then if you peer networks, the other network will be able to see the VNet-local endpoint of SQL Managed Instance. So woohoo, You can peer two networks with two SQL MIs, and you can set up an auto failover group. This is the quintessential scenario. One good thing, Nico actually told you about this. Because the domain name for the VNet-local endpoint is publicly resolvable, after you peer networks, there's no extra steps you need to do. Both VNets will be able to resolve the IP address. The first one, clearly, where the SQL MI is, because the IP address of the VNet-local endpoint is from its range. And then the other one automatically gains the ability to do so because it already knows the IP address, and now it can send the packets and receive them back. Traffic filtering still applies, firewalls, NSGs, and then there are additional configuration options for the peering itself, such as one-way peering or peering that blocks traffic coming, foreign traffic, and so on. So you can configure this to your heart's content, or at least to some degree. In peering, you would typically use peering with when you need low latency access to the VNet-local endpoint. So replication, autofailover groups, distributed transactions, you'll typically want to use peering. I've listed the pros here, performance and access to VNet-local endpoint. There are some cons. The entire address space has to be shared. The traffic is not encrypted. Typically not a concern if you're staying within Azure because all the traffic goes through Azure backbone, but still it's not encrypted, so it may be a concern for some auditors or compliance checkers. And the third thing to keep in mind is that peering is not transitive. If you have three virtual networks, and you peer A to B and then B to C, this does not imply that A can traverse B magically and reach C. So that doesn't work. You would have to connect them in a triangle, peering everyone to everyone. This is solved by virtual private networking. VPN is, again, a major mechanism in the networking topology world. How do you connect different virtual networks or networks in general? Well, you would use a gateway. A gateway is a component that deploys inside the virtual network, and it exposes an IP address that is where the gateway is, and then using this, you can route traffic to and from different virtual networks. They exchange encrypted traffic, and in this instance, we're talking about VNet to VNet VPN. There are three types of virtual private network connections you can set up in Azure: VNet to VNet, point to site, and site to site. We've talked about point to site, and now we're mentioning VNet to VNet, which is a special case of site to site. So just briefly going over it, with VNet to VNet VPN peering, you can actually set up custom architectures, and you can configure which virtual network gets to talk to each other, whereas in peering, you couldn't do that as easily, and if you wanted to do some involved scenarios, that would actually probably cause you to run out of IP space pretty fast. The third thing is that VPN works hand in hand with peering. There is this feature called gateway transit. If you have two networks connected with VPN, and one of them has other networks peered to it, you can enable gateway transit, and then the peered networks will also automatically use that gateway to reach the network on the other side. You can use this in advanced topologies to create advanced topologies when you really need access to the VNet-local endpoint, such as security and geo-zoning. Again, auto-failover groups, managed instance link, and so on. The pros are obvious. Cross-traffic is encrypted, and you have this peering gateway transit, and the routes are better configurable than if you were doing just peering alone. But the cons are that the entire address space is shared, there's higher latency, and of course, the gateway SKU that you have selected will cap throughput. And finally, private endpoints. Private endpoints are one-way connectivity. If there are any networking gearheads here, they will probably skewer me, but I have to say they are site-to-point connections. It's not a term that I've heard being used, but yes. With private endpoints, you can airlock your SQL managed instance, put it in a VNet, and close everything off that can be closed, and pass your regulatory compliance, because private endpoints will traverse the NSG and firewall rules, and they have their own security mechanism. How? When there is a request to create a private endpoint to a resource, that resource operator, resource admin, will have to approve it manually. Okay, maybe it's an app, maybe it's a human, maybe it's a service, but still, this incoming request has to be approved. You just don't get to automatically hook up into someone's managed instance or anything else for that matter. And lastly, and perhaps most interestingly, instead of peering, if you really just want to enable some other service to query data in SQL Managed Instance, why don't you just bring a private endpoint and that consumes just one IP address rather than the entire site or block? So a private endpoint will consume one and only one IP address, and this can even be a reserved IP address that you have pre-selected, and it will never change. If the MI fails over, if the MI gets moved to a different subnet, whatever happens to SQL Managed Instance, the IP address of its private endpoint will remain the same. You will perhaps experience a short interruption during the failover, and that's it. Only use this, and use this when you only need access to the SQL query listener, port 1433. It won't support more complex scenarios. There is a managed instance gotcha. All connections similar to the public endpoint will be of proxy type, and you also need to set up DNS resolution. Again, I'm not at liberty to say if this is forever or not, but for now, you have to set up DNS resolution because connecting to a private endpoint or a public endpoint or any kind of endpoint by using its IP address will fail to send sufficient information to the virtual cluster, and the connection will not be routed properly. So always send in your SQL connection strings, always include the full host name and the domain name of the instance. That way, you will connect. So here's an example of a fairly involved, I can't say it's fairly involved, but a network topology that uses all mechanisms here. And you can think of this as, here's a hub and spokes, and then maybe some sort of like analytics department doing something. There's a gateway in between, peerings and private endpoints. So with these three mechanisms, you can implement pretty much anything, and any network admin will know that this is similar to what you would be doing on-prem as well. All right, secure connectivity across Azure. You can perhaps partner with other organizations in Azure, or maybe some ISVs who have Azure presence, but they belong in a different tenant. How do you exchange information with them? Many ways, but I have selected two. Either a private endpoint in their virtual network, or a more flexible setup that involves a site-to-site VPN. So let's quickly show them. The simplest way would be to just allow this other tenant or your customer, partner, whomever, maybe your subsidiary, hey, create a private endpoint. How do I do that? Well, you run, as a managed instance admin, you run an AZ resource list, --name, the name of your MI, and you get the resource ID. This is the ID of the resource that they want to create the private endpoint to. You email it to them, and then they go to the private link center and create, oops, sorry, I just went back. They go to the private link center, and they create a private endpoint using the resource ID, and then the sub-resource is the actual name of the subnet. So, oh, this is shifted. OK. And then after that, the admin of SQL Managed Instance still has to go and check, is this what we wanted? Where is this coming from? And did I get a message that I was expecting? Who is this? It's Eric from Contoso. OK, apply. Magic. So this is very good, but it won't really scale well if you're managing 47 clients with 5 or 7 private endpoints each. It doesn't scale very well. And one other thing, perhaps you don't really want to expose the resource ID of your managed instance, because that might open up some interesting questions. Why am I sharing? Why am I using the same managed instance to someone else? Like, I want a bigger one or whatever. What to do then? Create a virtual network and use site-to-site VPN to connect it with another virtual network that's owned by that other tenant. So they have a VNet, we have a VNet. We set up site-to-site connection, and then in this VNet on our side, we will drop as many private endpoints as we like. Sorry. Yes. We can drop as many private endpoints as we like, and then the peering will only happen between those two virtual networks. We retain the ownership of creating and removing private endpoints. The customer on their end, or the partner tenant on their end, doesn't have to concern themselves with creating private endpoints or doing anything. They don't have to set up DNS resolution. We can do it on their behalf. So this would be a more scalable way of achieving a similar thing of cross-tenant connectivity. Similar, again, gateway will cap this throughput. OK, so these are the secure connectivity scenarios that we looked at across Azure. And I also want to talk about the fifth scenario, which is secure connectivity between on-premises and Azure. So we're talking now about hybrid and mixed scenarios. This is interesting if you want to plan a migration from on-premises to Azure, or you want mobile or temporary connectivity. this is something that we commonly use. When I flip open my laptop at work, I will VPN into it. I can also use this. I should also consider one of these scenarios if, for example, I have a few clients, a few customers who have their own on-premises, but it's not a big overhead to manage them. Or I can think about more permanent connectivity, persistent and reliable connectivity, which is something for mission critical. So there's a broad range of scenarios here that we're going to cover. And there are 3 mechanisms: the previously discussed point-to-site, then site-to-site, and of course, Azure Express Route. I just have them all in one slide because we've seen them, except Express Route, we've seen them all. So point-to-site is great to handle temporary connectivity, a worker logging into their work account, or a small number of clients who just don't need really high throughput connectivity. Site-to-site VPN actually does require you to purchase a hardware gateway on your end, but it gives you a better, more performant, more secure connectivity. It will suit all but the most intensive workloads. So typically, we've seen this in use for development and testing for some small-scale productions. SMEs use site-to-site connectivity a lot. Past that, there's Azure Express Route. Azure Express Route is a dedicated link that you will take to an edge provider or directly to Microsoft. And then this link will continue on into Azure. What's good is you don't really share this. There's nothing by way of public internet. You have a dedicated physical link. You should consider Azure Express Route if you're attempting mission-critical hybrid scenarios. And through this, you can get access to the entire Microsoft Cloud Platform, Azure Office Dynamics, whereas site-to-site VPN will only let you access Azure. A couple of other things. How are we with time?
Oh, very good.
Very good. OK. Another thing that you should also consider, Azure SQL Managed Instance works with pretty much everything, but a couple of other things that you should think about as you design and as you consider migrating. Service endpoints and service endpoint policies that Nico mentioned, they are an excellent tool to protect you against data exfiltration. So you can police your outbound traffic and say this outbound traffic from where my SQL Managed Instances can only reach 1 or 2 designated storage accounts. This also means, when I say outbound traffic, this means SQL MI trying to read or write. It's a little bit confusing. I myself have been confused by it. But outbound traffic means SQL MI is reaching out into Azure storage to do something. That can be either backup or restore or anything else. Azure Monitor and Microsoft Sentinel you should consider for observability, analytics, and telemetry. There's also Microsoft Sentinel is, I believe, an enterprise-level tool, enterprise-level SIM management. It also has security intelligence built in from Microsoft Cyber, what are they called? Cyber Defense Group, yes. So consider that as well. Microsoft Defender, I mentioned it previously on the Trolls slide. It will offer you security measures and best practices against a set of known vulnerabilities. It will also display you alerts, provide recommendations, security baseline, and so on and so forth. Azure Network Watcher is a set of tools for your network administrative needs. Availability, performance, discovery, diagnostics, resource planning, security rules, all kinds of stuff. Azure Policy allows you to audit what's going on with Azure SQL Managed Instance and enforce compliance. For example, you can create an Azure policy that says, do not allow the creation of a managed instance that has a public endpoint open, or disallow the action of enabling a public endpoint. And they are actually very powerful. If you look into what's happening with Azure policy, you can enable all sorts of stuff.
Just a question. How many of you are using Azure policies? This one is like sometimes. Okay, one. Okay, good.
Yes. We have some built-in policies that you can apply immediately, and I believe SQL MI, don't hold me on this, but I know that there are existing Azure policy suites, or as we call them, initiatives, that you can enable to ensure HIPAA compliance, FISMA compliance, different levels of FedRAMP, I think, moderate, and FedRAMP, also what's the other one called? I forgot, sorry.
A good example of setting up a policy would be forcing some of the best security practices and connect it to the connectivity, which would, eliminate even possibilities for other administrators of doing a job in a wrong way. Maybe there is some member of the team who is new to be onboarded, and without Azure policy, you open for any custom changes. And then all of you, even on the SQL Server, I'm sure, you know how much time you will spend just looking who did it, what was exactly done, and then trying to find out how to solve it. And problems have already occurred in the meantime.
Thank you, Nico. That is a good call out. All right, so Azure policy. Next, managed identities. Managed identities, if you don't know, they are an Azure AD construct, and you can think of a managed identity as I think I already used this. A managed identity is a membership card that has written on it what the holder of this card can do. So you can issue this identity to a service or to a user, and then when they can use it to authenticate with a service and perform an action or not.
You can actually, those of you who are young enough, managed service accounts. Think of them as managed service accounts, but globally on Azure.
All right. The blue callout is that SQL Managed Instance supports both system-assigned and user-assigned managed identities. System-assigned managed identity is assigned to the managed instance when it's created. It can be toggled on or off. And user-assigned identities allow you to assign any number of identities and then just program what happens with them.
And actually, one of the cool tricks that you can do is you can create a user-assigned managed identity, and then you can run multiple instances in your environment with the same user-assigned managed identity. And this way, if you need to guarantee the access of multiple managed instances to the same resources, you don't need to go into every individual one and tune it and make sure that you didn't forget one of them, but you're using this managed service account just once, you'd update it, and all the managed instances that are using it are automatically updated to the same rules.
That is very useful. Thank you. Yes. OK, three things that are near and dear to my heart, at least in terms of showcasing where Azure is going, are Azure Virtual Network Manager, Azure Virtual WAN, and DNS Private Resolver. They are at-scale management tools. They are tools that you would not easily find or not at the equal compatibility and functionality on-prem. Azure Virtual Network Manager is a tool that allows network admins to manage their networks on a global scale. And it contains several modules that do different things. One allows you to group virtual networks into logical units and then apply different security rules on them. One allows you to connect them in a mesh or a hub and spoke connectivity patterns, and then the other one, the third one is, I forgot what it does. But, yes.
At least something, we found something we have forgotten.
Some things have been found, yeah, what the water brought and what the water took away. One thing to keep in mind, the light blue callout, SQL Managed Instance does work, of course, everything works with Azure Virtual Network Manager, but the question is, what happens if a network administrator overseeing the operations of the entire Azure presence of a company, what happens if they close the pipe on all ports? Let's say they want to say, I will disallow any port on in range 3,000 and above, because there's nothing there. There's nothing going on there. I mean, that would be a paranoid network admin, but let's imagine they do so. They would actually override our NSG rules, keeping the managed and keeping the public endpoint open. So this can happen. There is no way to override what AVNM does. It has the highest priority. What you can do in that case is go and talk to the network admin and talk some reason into them, or perhaps what's going to be easier, to ask them to apply only the allow rules. So from the entire set of rules that they are applying to the subset of virtual networks where SQL Managed Instance is, ask them to narrow this down, and they would only apply the allow rules, keeping those ports open, and not apply any deny rules. This has worked, and I have word from the AVNM folks that they'll continue working on this. So, yeah. Azure Virtual WAN is a smart, integrated global transit hub and spoke architecture. It's a lot of words together, but it is a set of tools that allow you to create global architectures with gateways and private peerings and everything in an easier way than if you were just to hook it up by hand. And a similar role is played only in the DNS resolution world by the DNS private resolver, which absolves you from the responsibility of setting up individual virtual network to virtual network resolution rules. Oh, how do I get this private DNS zone to resolve over there and over there, but over there I don't want it to resolve. It allows you to get all this done and cut through the red tape. Lastly, Azure Firewall is a fully managed from IP level all the way to the application level, threat intelligence-based filtering solution. It comes in different SKUs. Really, I don't want to bore you with it. Look it up, but it's very powerful. It allows you to do traffic inspection, web filtering, TLS termination, all those other things. And with that, I would ask you to ask us any questions and possibly leave us feedback. Thank you.